Hello everybody, and this side Vanshika. You are watching my channel Knowledge World. So today in this video lecture we are going to know about the chapter of class 8 NCERT, and the chapter is chapter number 11 and force and pressure. The chapter's name is force and pressure. So this is the first part of this chapter, and there are three more parts which will be uploaded soon on my channel, so you can check all these four videos, and the videos are not more than 15 minutes, so you can easily check all the videos. So let's begin with our chapter. Today we'll be going to study this chapter from online notes of Ask IIT and site, like all other chapters we cover on my channel. So let's proceed with our chapter. I'm just opening the notes and then we'll start with the introduction of force and pressure and the further topics. So I have opened the notes of force and pressure. So the first bullet point, when a push or pull is to an object, it is called force. So what is force? It is the push or pull applied to an object. So let us know what is push and pull, because students are having confusion between push or pull. So let's first understand the word push. See, when we push something, the object moves far from us. There is only one definition for push, that when we push something, then the thing moves away from us. When we push the door, or when we push someone, when we push a child, then the child moves away from us. When we push the ball, then the ball moves away from us. When we push the door, then the door moves away from us. And on the other hand, however, when we pull something, then the thing comes towards us. If I will pull someone, then the person will move towards me. If I will pull something, then the thing will come towards me. So I think push and pull both are clear, and force is also clear with the same. So a push or pull is applied to an object, and that push or pull is regarded as force. A force can change the state of an object from rest to motion, or vice versa. This means that a force can change the state of an object which is moving. Either it can stop the motion, it can bring the object to rest, means it can make the object stationary, or it can make the object which is in rest or at stationary position to move or motion. So vice versa, I have explained both types, that force can change the state of an object. How can we justify the statement? That either the force can can move the object which is at rest, or can bring an object which is in motion to rest. Means if some object is moving, it can also make it to rest position, or if some object is at rest position, then it can force can make it move also. So in this way, a force can change the state of an object. To let a force come into play, two or more objects must interact with each other. So from this statement, we get to know that there should be an interaction between two or more objects if force needed to be applied. So if we need to apply a force, then we need two or more players, or two or more objects to for force to come into play. So we should have two or more objects and their interaction also. So I think these 3 points are clear to you. So here are some examples of force in figure 1. You can notice them. The goalkeeper, see, in the first condition, the goalkeeper is bringing the ball at rest because it was in motion, and he is stopping the ball. So he is making the ball at rest, or bringing it at the stationary position. However, in the second one, what's happening? The player is pushing the ball, so it is moving away from him. He is not making it at rest, he is making it move. so the ball is moving. In the third condition, he is stopping the ball, so he is making the motion of the he's converting the motion of the uh, object to rest. So the object is coming in rest position, the ball is coming in the rest position. So these were the three conditions, or depicted as figures. Do magnets also exert a push or pull? So something like a question is given here and we will study about it. So, do magnets also exert a push or pull? We know that a magnet can attract a piece of iron, because iron, nickel and cobalt can be attracted by magnet. Hence, we can say that the magnet pulls the iron piece towards itself due to its magnetic force. Yes, we can say that it is pulling the iron piece because of the magnetic force. Similarly, when opposite poles of a magnet repel each other, we can say that they are pushing each other away. See, we can understand the concept of push or pull from the example of a magnet also. If we are putting an iron piece and we are having a magnet also, so what will the magnet do? The magnet will pull the piece of iron towards itself. However, when we have two same poles of magnet, then what will happen? Then repulsion will take place. When we have same poles of magnet. Then when repulsion will take place, then they will push each other. So in this way we can understand this concept. Now, what are the characteristics of forces? When two forces act in the same direction, the net resultant force on an object is the sum of these two forces. So, I would like to show you this diagram. So, the two boys are pushing this box in the same direction, means they are standing in the same direction, in the same position, and they are pushing the box in a direction, and they are pushing the box in the left direction, and they are standing in this. I would like to repeat it again, that they are standing in the same direction, in the same position, and pushing this heavy box towards the left direction. So there are two forces, F1, we can say F1 and F2, means force 1 and force 2. So when they are pushing this box towards the left direction or towards the direction of the arrow, then both the forces are acting and they will get added. The forces F1 and F2 will get added, and the total force means F1 plus F2 will be is equal to the net force. Means we will be getting the total force when we will add F1 means force 1 and F2 force 2. So when we will add both the forces, then we will get the correct force applied on the box. I hope it is clear. And we will end that resultant force is the sum of two forces. Resultant force is the net force. The second condition is given here. Now, when two forces act in opposite directions, the net resultant force is the difference of these two forces. The force has a magnitude which describes its strength. So, now the two boys, I would like to show you the diagram. Yes, now the two boys are applying force from different directions, from opposite directions. So the net resultant force is the difference of these two forces. As when they were applying force from the same direction, then they were getting added, means the resultant force was the sum of both the forces. Now in this condition, the resultant force is the difference of both the forces. Means we will subtract both the forces in order to find the net resultant force. One more important point which we should focus on here is the force has a magnitude which describes its strength. So, if somebody asks that what is magnitude, so we should say that the force has a magnitude which describes its strength. Means magnitude is equal to how much force applied. You can say this also. How much force applied is equal to the magnitude. So in this figure they were showing that force is acting in opposite directions. Now these points we'll study some important points. The first point is the force always has a direction in which it is applied and a measure of its strength or magnitude. So a force will always has a direction in which it would be applied. There will always be a direction in which it will be applied, the force will be applied, and there will always be a magnitude or something. Magnitude is what? Magnitude is something which is used to measure, which is telling us that how much force is applied. So a force always has a direction and a magnitude. The second point is the effects of a force may alter when the direction of the magnitude of the force is changed. So the effect of the force may vary or may change when the direction of the magnitude of the force is changed. Means when we change the direction of the force, so effect may change. So the next point is next point is the effect of more than one forces being applied on an object is calculated by evaluating the net force acting on the object. So the next point is the effect of more than one forces being applied on an object is calculated by evaluating the net force acting on that object. So if we want to calculate the effect or the quantity of a force, I should say, to make it easy for you, so if we want to calculate the effect of one force being applied on an object, so we have to evaluate the net force, means the total force acting upon the object. If two forces are acting upon each other having equal magnitudes or strength and in opposite directions, so this point is if two forces are acting upon each other having equal magnitudes, means from both the sides equal force is applied or equal strength is applied, so the net force will be 0, means the object will not move and the force will be 0. The next point is force can bring different effects to an object's position, size and shape. Means force can bring different effects. It can affect the position of the object, it can move the object for the size and shape of the object also. So force is now these formulas are there. So force is equal to mass into area, then F is equal to force, m is equal to mass of the object, and a is equal to acceleration or area. So the next we'll study in the second video. Bye bye till then and have a nice day. And if you like the explanation, so please like a video, share the video and subscribe to the channel for more such videos. Please subscribe to the channel and press the bell button to get the latest notifications of all the new posted video. Thank you for watching the video. Stay tuned with me and keep watching Knowledge World.